The General Electric F404 and F412 are a family of afterburning turbofan engines in the 10,500 euro 19,000 pound force class. The series are produced by GE Aviation. Partners include Volvo Aero, which builds the Room 12 variant. The F404 was developed into the larger F414 turbofan, as well as the experimental GE 36 civil propfan. Design and development, F404. GE developed the F404 for the F/A-18 Hornet, shortly after losing the competition for the F-15 Eagle's engine to Pratt & Whitney, and losing the lightweight fighter competition to the Pratt & Whitney F-100-powered YF-16. For the F/A-18, GE based the F404 on the YJ101 engine they had developed for the Northrop YF-17, enlarging the bypass ratio from 0.20 to 0.34 to enable higher fuel economy. The engine was designed with a higher priority on reliability than performance. Cost was the main goal in the design of the engine. GE also analyzed throttle profiles, and found that pilots were changing throttle settings far more often than engineers previously expected, putting undue stress on the engines. GE also sought with the F404 a design that would avoid compressor stalls and other engine failures, and would respond quickly to control inputs. A common complaint of pilots converting from propeller planes to jets was that early turbojets were not responsive to changes in thrust input. GE executives Frederick A. Larson and Paul Setz also set the goal that the new engine would be smaller than the F4's GE J79, but provide at least as much thrust, and cost half as much as the P&W F100 engine for the F-16. Due to a fan designed to smooth airflow before it enters the compressor, the F404 has high resistance to compressor stalls, even at high angles of attack. It requires less than 2 shop visits per 1,000 flight hours and averages 6,500 hours between in-flight events. It also demonstrates high responsiveness to control inputs, spooling from idle to full afterburner in 4 seconds. The engine contains an in-flight engine condition monitoring system that monitors for critical malfunctions and keeps track of parts lifetimes. GE developed the F-110 for the Air Force as an alternative to the Pratt & Whitney F-100 for use on the F-16 and F-15 based on the F-101 and use F-404 technology. GE developed the F-404 GE-402 in response to a Swiss requirement for more power in its F/A-18 version. The new engine version was used on Q-80 Hornets, later US-C&D Hornets, and subsequent Hornets. The T-50 Golden Eagle uses a single General Electric F404-102 turbofan engine with full authority digital engine control system. The engine consists of 3 staged fans, 7-axial stage arrangement, and an afterburner. The aircraft has a maximum speed of Mach 1.4. Its engine produces a maximum of 78.7 kN of thrust with afterburner. Almost 4,000 F404 engines power the F/A-18 Hornets in service worldwide. The F404 engine family had totaled over 12 million flight hours by 2010. F412, GE developed the F404 into the F412 GE400 non-afterburning turbofan for the McDonnell Douglas A-12 Avenger II. After the cancellation of the A-12, the research was directed toward an engine for the Super Hornet, which evolved into the F414. Applications: F404, Boeing Phantom Ray, Boeing X-45C, FMASAIA-90, Dassault Rafale A Grumman X-29, HAL Tejas Mk1, Lockheed F-117 Nighthawk, Kai T-50 Golden Eagle, McDonnell Douglas F/A-18 Hornet, Northrop F-20 Tigershark, Rockwell MBBX-31, Saint Aerospace A-4SU Super Skyhawk, F-412, McDonnell Douglas A-12 Avenger II, engines on display, Patuxent River Naval Air Museum, specifications, general characteristics, type, afterburning turbofan, length, 154 inches, diameter, 35 in, dry weight, 2,282 pounds. Components: compressor, axial compressor with 3 fan and 7 compressor stages, combustors, annular, turbine, 1 low pressure and 1 high pressure stage, performance, maximum thrust, 11,000 pound force military thrust, 17,700 pound force with afterburner, overall pressure ratio, 26:1 bypass ratio, 0.341, specific fuel consumption, military thrust, 0.81 pounds/lbfah, full afterburner, 1.74 pounds/lbfah, thruster-weight ratio, 7.81, see also, related development, General Electric YJ101, General Electric F414, General Electric F110, Volvo RM12, comparable engines, GTRE GTX35 vs K-Very, Guizzo WS13 Klimoff Road 33, Snecma M88, Turbo Union B199, related lists, list of aircraft engines, references. Jenkins, Dennis R. FA-18 Hornet, A Navy Success Story. New York, McGraw-Hill, 2000. ISBN 0-07-134696-1. External links, GE F404, F404 page on globalsecurity.org,